Hello everyone, welcome to my session. First, I want to thank Conf42 for organizing this conference. Now, let's talk about the carbon emission of your cloud infrastructure. I'm Olivier Bierlaire. I'm usually software engineer at Elastic in the releasing team, but I'm taking a break to work on Carbonifer. Carbonifer is a platform for managing, measuring, and reducing the carbon emissions of your cloud. Here is a sentence I hear quite often. I have all my infrastructure in the cloud, so I do not emit CO2. Yes, we all know that whatever you put in the cloud disappears. It's just magic. It doesn't have physical existence. But still, we know that it's running on servers and data centers, and those are powered by electricity. But electricity is clean, right? No, not really. So let's talk about electricity first. Let's look at some numbers. We considered that data centers are responsible of 20 to 25% of the electricity used by the digital sector, which is 1.3% of the total electricity used worldwide. And if we look at some projections, we considered that by 2030, the digital sector is going to be responsible of 20% of the worldwide electricity demand. And amongst that, the data centers are going to be responsible for a third. If we talk in terms of greenhouse gas emissions, we consider that the cloud is emitting more than 300 megatons of CO2 yearly, which is around the same carbon footprint as countries like France or UK. We have recently overthrown the civil aviation. Basically, the cloud is emitting more CO2 than flights. And these numbers can be around 8% by 2030. 8%, that's huge, and that's concerning as human being, but it's also concerning as company. Why? Because there is some regulation and laws that are coming. Looking at the carbon footprint of a company is also a great way for attracting ESG funds. Those funds are investing money in companies that are showing some sustainability, and obviously, as a company, you want to attract them. It's also a great tool for recruitment and staff retention. You are more keen to join a company if it's showing some ethics and sustainability, and there are some studies that are showing that. It's also great for customer retention for the same reason, and that could also lead to some cost reductions. So in order to know what the company is responsible of, there is three scopes. The first scope is your direct emission. So basically, if you are burning fuel or if you have a diesel generator, for example. In scope 2 is your indirect emission related to purchase of energy. So basically, that's your electricity bill. The scope 3 is basically everything else, other indirect emission, value chain emission. So it's basically your business travel, purchase of servers, and even the purchase of cloud services or your subscription to a cloud provider. So basically, if you are running your infrastructure on a private cloud, that means the electricity used by this private cloud is going to be accounted in your scope 2, but the purchase of those servers is going to be accounted in the scope 3. If you are running only on public cloud, that means everything is going to be accounted as the scope 3. So what should we put in the scope 3? For example, Mozilla had a very wide definition of the scope 3 in their sustainability report in 2019. They counted the use of their product, and they discovered that 98% of their carbon footprint is coming from the usage of their product, basically people using Firefox. And there is even some people that are thinking of counting as the scope 3 even things like Spotify. For example, if you need to have music streaming while you are working, while you are coding, should we account that as the scope 3 of your company? Because you need it, so you have emitted CO2 for your work at your company. So where should we stop? So basically, companies are responsible of defining the perimeter of their scope 3. In terms of regulations, there are some directive and laws coming in the next years. For example, in Europe, you have the CSRD. CSRD stands for Corporate Sustainability Reporting Directive. It's going to be enforced in 2024 for large companies, and in 2 years for listed SMEs. It's going to be for scope 1 and 2, and even scope 3. The SFDR is for financial companies, so they will need to account as their scope 3 the carbon footprint of the company they are financing. And in US, you have the SEC climate disclosure rule, which is encompassing scope 1 and 2 and even scope 3 as optional, and it's going to be enforced pretty soon. So here are some terms you probably have heard. If we are talking about CO2 offsetting, that means we are doing some compensation or removal. Removal is basically direct air capture, removing CO2 from the atmosphere. Compensation is giving money to some project, which is helping offsetting CO2, basically planting trees. If we are talking about elimination, that's obviously mean we are not emitting CO2, we are eliminating the source of CO2. So if a company is talking about being carbon neutral, that means they are not necessarily looking at their emissions, but just focusing on offsetting. So they are emitting the same, and they are just compensating or neutralize all their emission by, again, planting trees. If we are talking about being net zero, that means we are focusing on elimination. We are reducing the CO2 that we are emitting, and we are offsetting the rest. If a company is talking about 100% being renewable, that means they are using only renewable electricity. But is it powered by or matched by? Powered by, that means you are sure that the electricity coming in the data centers are coming from renewable energy source. If it's matched by, that means, for example, if they are producing twice their need with solar panel, and but during the night they still need to buy electricity on the market. So in that case, it's matched by. It's a little bit less interesting. So now, how we can measure your cloud infrastructure and the carbon footprint of your cloud infrastructure. So how it's working? Electricity is produced different ways. For example, coal or gas plants, nuclear plants. For example, side note, in this presentation, nuclear is considered as clean energy because it doesn't emit any CO2. It could be also produced by renewable energy, solar panel, windmills, and hydroelectricity. So all these means of all of these generator of electricity is mixed in what we call an energy mix, and this electricity is translating over your regional grids. And when it enters the data center, a little bit of this electricity is taken for powering the administrative building, the air conditioning, the heating, etc., etc. But the large majority of the electricity is for the servers. So if you have a cloud infrastructure on a public cloud provider, that means you will have VMs, containers, applications running on those servers, and you can take a ratio of the electricity powering uh, this data center for your own component for your needs. So in order to calculate that, the Green Software Foundation came up with this SCI formula. SCI stands for Software Carbon Intensity. So the idea with that is to calculate how many grams of CO2 per hour your software is gonna emit. So let's look at the end of the formula. What is the M here? It's called embodied emission. So embodied emissions is emission generating during the manufacture, the delivery, and the disposal of your hardware. So for example, if you bought a server and the server required 4,000 kilograms of CO2 to be manufactured, that means virtually every year you will emit 1,000 kilogram of CO2. So you can do the math for knowing the ratio per month, per hour, per process, etc., etc. The usage emissions are the emissions during the use of your software. So for example, if you are running AWS M4 large machine with 2 CPU and 8 GB of RAM during 50% with 50% use by your process, there is some ways to calculate that it's going to use 10 watts during an hour. So there's different ways to calculate that. The easiest way is to use some probes, but if you are running on the public cloud, you don't have access to the hardware. So in that case, there is some different ways to calculate that. So let's assume it's 10 watts during an hour. We multiply that by the power usage effectiveness. The power usage effectiveness, PUE, is how many kilowatt hour I need to inject in the data center in order to have 1 kilowatt hour. So in AWS Ireland, we consider the PUE is 1.2, which means we need 1.2 kilowatt hour in order to have 1 kilowatt hour usable by the servers. We multiply that by the carbon intensity of the grid. For example, in Ireland, we consider that the kilowatt hour generated 300 grams of CO2 during an hour. So that means that the energy mix, the different ways to generate electricity in Ireland, the average during a year is going to emit 300 grams of CO2 per kilowatt hour. So if you multiply all of that, we have the greenhouse emission in gram of CO2 equivalent per hour. So we're talking in gram of CO2 equivalent because not only CO2 are emitted when we are generating electricity, that could also be methane, CH4. The methane is 84 times more potent as greenhouse gas as the CO2. So in order to ease calculation, we are talking of gram of CO2 equivalent. So if we circle back to the SCI formula, if we multiply E by I, which is the emissions of the use, we have 3.8 gram of CO2 per hour, and then we take the ratio of the embodied emission, basically the manufacturer of this hardware, and in this calculation is 1.2 gram of CO2 per hour, and the SCI is now 5 gram of CO2 per hour. So where should we find this data? All those average carbon intensity of regional grid are really well known. It's pretty easy to find, and you even have this map, this application named electricitymaps.com. With this application, you can browse a map where you can click on some countries and have live carbon intensity of the regional grids. In this example, in March 22, in France, it was emitting 157 grams of CO2 per kilowatt hour, while in US, in New York region, it was emitting 100 grams of CO2 more than France. PUE is also pretty easily available data. So for example, we have all major cloud provider PUE per data centers. There are data that are less available. For example, the CPU, memory, and the storage, the energy consumed by this hardware. For example, if you are running on the public cloud, it's pretty difficult for you to have access on the name of the CPU, the brand of the GPU, the type of memory, etc., etc. And you need to have that in order to calculate what the power needed by those, and you need to have their power profile, etc., etc. So in order to ease that, we are using estimation and coefficient. So with estimation, it's sometimes sufficient to have rough number and to have some relative calculations. But you need to be careful. For example, if you are using Gravitron instance on AWS with ARM CPU are really efficient in terms of energy. It can be lower than 1 kilowatt hour, while legacy CPUs could climb up to 8. So you need to be careful with those estimations. The embodied emission of the hardware, again, the emissions generated during the manufacture of this hardware. To know that, you need to know what is the brand of the hardware, where it has been produced, and when, and this data is pretty impossible to get if you look at your AWS or GCP console. But fortunately, we have some data sets around and some benchmarks. And the energy mix is pretty difficult to predict. Obviously, to know what was the electricity mix in the past and to have the carbon intensity of some regions in the past is pretty easy to have. But in the future, in 1, 2, 3 weeks, 1 month, it's pretty impossible to guess. In order to ease that, fortunately, we have some tools. So major cloud providers like AWS, GCP, or Microsoft Azure have released a carbon footprint tool, dashboard, or calculator. With that, with one click, you can have the carbon footprint of your infrastructure per month and per account. If you want to dive in a little bit more, you have tools like Cloud Carbon Footprint. It's an open source tool and basically reads the bill of your cloud provider and get how many instances, what type of instances, during for how long, what kind of serverless services you use, like Lambda or anything else. And it gives you those CO2 emission per day, and you can even do some nice comparison, for example, knowing how many flights from New York to London it is similar. And yeah, you have a lot of nice things in this dashboard. If you want to be more accurate, you can use tools like Scaphandra. So basically, Scaphandra is monitoring CPU power. So it's using some probes to get what the actual electricity is used by your CPU. So obviously, you will not be able to use that on the cloud, but if you have access to your physical machines, that's pretty interesting. It's not directly telling you the carbon emissions, but you have the most complicated part, which is knowing the electricity used by your software. You have some interesting APIs like Climatic. Climatic is a commercial API, not only for the cloud, also for different sectors like freight or agriculture or anything, you name it. And among that, they have cloud computing. So basically, you can query this API asking them, hey, I have an instance running on AWS for this time, and it's going to give you what is the carbon emissions of that. You can also use tools made by Boavista. So those are free open source tool, and you have the Boavista API. Same thing. You can query. I have a machine running on AWS M4 large during 1 hour, and it can give you what is the CO2 emitted during the use of this instance, and it will give you the manufacturing emission, the embodied emission for the entire lifespan. And finally, my little tool named Carbonifer. So basically, Carbonifer is able to read Terraform projects. So if you don't know Terraform, Terraform is an infrastructure as code tool. So as a code, you will describe what is the infrastructure we want to have deployed, for example, on GCP. So in this example, you have a E2 standard 2 instance. You want to deploy it in Europe West 9. And if you run Terraform plan and Terraform apply, sorry, it will deploy it on GCP in the region you pick, and that's what Terraform is. So Carbonifer is pretty similar, but instead of deploying, it will read your Terraform project and try to estimate the carbon emissions. Um, and Yeah, so basically it's reading your Terraform infrastructure as code files and try to make some estimations. Obviously, those estimations it will not be accurate. It's just rough estimation, but it's already a good way to make some comparison and take some decisions. There is some tools in this awesome list powered by the Green Software Foundation. I strongly encourage you to check those out. So now we know how to measure your cloud infrastructure, how we can reduce it. Obviously, if you are running a poorly designed, not optimized code on your infrastructure, the only way you will get the performance you want is by increasing the size of the machine. So obviously, you need to optimize your code and use some eco-design good practice for your software. Once you have done that, very good practice is to choose the right instance type and the right generation of CPU. For example, you can use Gravitron instance on AWS and choose exactly the size you want. You not necessarily need to overcommit. And obviously, a nice way to lower your carbon emission is to move to hyperscaler. So all major hyperscalers, public cloud like AWS, GCP, and Microsoft Azure are claiming to be net zero or even carbon negative by 2030. They are making a lot of improvement on their PUE, on the lifespan of their hardware, and buying more and more renewable energy. Uh, One thing would could be also interesting in looking at alternative cloud providers. For example, Denver in France is deploying some floating data centers. So basically, they're going to be naturally cooled down by the stream. So those are really interesting to check. So basically, if you have all your servers on premises, you tend to have numerous underused servers, just in case you will have a surge of traffic. If you are on the cloud, you can adjust it to the bare minimum and have fewer highly used servers, which leads to uh, using less resources and then emitting less CO2. So basically, you would like to use some finops good practices in order to be greenops, basically. So finops is a way for better controlling the cost of your infrastructure. For example, if you are bringing some automation to shut down instances during the night or adjusting the number of instances to your traffic, which is called auto-scaling group. In that case, you will pay only what you need and not more. And in that case, you're using less resource. And again, you're emitting less CO2. Be careful with the reserved instance. With the reserved instance, you're going to save a lot of money, but it's going to be still the same amount of instance. So in that case, you will still emit a lot of CO2. Obviously, you need to pick the region which is having the best carbon intensity. So in this example, you have it's on Google platform website. You have the different regions in Europe, and as you can see, that could be as low as Paris with 70 grams of CO2 per kilowatt hour, up to more than 700 in Europe Central too. So you need to pick the region very carefully. And then if you want to be more fancy, you can move to carbon aware. So carbon aware is the ability of a software or an infrastructure to know its own emission and to adjust itself according to its own emissions. So the first things you can do is temperature shifting. So basically, temperature shifting is scheduling asynchronous task when the electricity is gonna be less carbon intensive. For example, video processing, AI training, machine learning, etc. So if you want to train your AI model, it's not necessary, you don't necessarily need to do it right now. You can wait for the electricity to be less carbon intensive. That's exactly what they are doing at Google for their own need. So basically, they are waiting for the right time frame to launch some synchronous task, and doing that, they lowered a lot their carbon footprint. Another thing you can do is demand shaping. So basically, demand shaping is doing more when electricity is emitting less. For example, lowering the quality of the video when the electricity is very carbon intensive, and go back to high definition when the electricity is less carbon intensive. Another good example is a CI server, adding more or less worker to the CI server depending of the carbon intensity of electricity. So basically, if it's a peak of CO2, during a peak of CO2, your developer are gonna wait a little bit more for having their PR built, and it's gonna go back to normal when the electricity is gonna be greener. Another good way is spatial shifting. So basically, spatial shifting is moving your infrastructure alongside with the carbon emissions of local grid. Or if you have two different data centers, picking the one with the greenest energy mix. So for example, in Carbon 23 conference, some people that are that they are doing that with two different data centers in two different regions. So they have a load balancer directing the request from the user to the data center, which is the closest to the user. And then they change it to take into account also the carbon intensity of those region where those data centers are. And by doing so, they manage to reduce their carbon footprint by 21%, which is already great, without any compromise on the latency. And with an acceptable latency, which means that the user will barely notice it, they manage to reduce their carbon footprint by 51%. So this is super interesting. So as a conclusion, if you want to be the less carbon intensive and to have your a greener cloud infrastructure, the first thing you need to do is collecting metrics. You cannot reduce what you cannot measure. So first measure it. Then once you have your metrics of your CPU, RAM, etc., you can estimate the power used by those, and then you can even estimate the carbon emissions in terms of gram of CO2 per hour. Once you have that, you can use some tools, some dashboards, some analytics to uh, make some thinking and correlation and come up with actions, reductions, resizing, and scheduling according to the intensity of the grid. And then if you can go carbon aware. That's all for me. Thank you very much for listening. If you want to know more, you can send me messages, but you can also check the Green Software Foundation website. They have very good material on this topic. You can listen to their podcast, and I strongly encourage you to also check boavista.org to have a lot of good documentation and tools for helping you on that journey. Thank you very much.